Alright, welcome back to the class. So we have 2 exponent x plus x equals 5. So 2 exponent x here is an exponential function or an exponential term, okay? Now x here is a linear function or a linear term. And then 5 here is a constant. Now to solve this, we need to apply the defining equation or the functional equation of the Lambert-W function. Now let's quote the formula. Alright, so this is the formula for the defining equation or the functional equation of the Lambert-W function. Now, this part of the equation is known as the Lambert-W function. This part is known as the argument, okay? And then this part is known as the output, okay? Alright. Now to solve the question given, we need to manipulate the question to have a form that looks like the argument so that we can do substitution. Alright, so our equation is going to be 2 exponent x equals 5 minus x. Alright, so you have 2 exponent x equals 5 minus x. Now let's divide here by 2 exponent x, and then this part also by 2 exponent x. Alright, now any number over itself is 1. So 2 exponent x over 2 exponent x is 1. So we are going to have 1. We are going to have 1 equals 5 minus x over 2 exponent x. Alright, so this is what we have. Now we can reorganize this equation. So we are going to have 1, okay, 1 equals 5 minus x times 1 over 2 exponent x. Okay, alright, so you can see we have reorganized the equation. Now, we know that if you have 1 over a exponent n, this equals a exponent negative n. Okay, alright. Now, this is called the negative power or exponent rule. Okay, so when we apply this to our question, we are going to have 1 equals 5 minus x, okay, multiplying 2 exponents negative s or minus x. Alright, so this is what we have now. Alright, now the goal of the process is to have a part that looks like the argument in the Lambert-W, the defining equation or the functional equation of the Lambert-W function in order to do substitution, okay? Now here we are going to multiply both sides of the equation by 2 exponent 5. Okay, so you're going to have 1 multiplying 2 exponent 5 equals 5 minus x multiplying 2 exponent x multiplying 2 exponent 5. Alright, so you're going to have 2 exponent 5 equals 5 minus x multiplying 2 exponent minus x, okay, and then here is 2 exponent 5. Alright, now alright, so this is what we have now. Okay, let's bring the 5. 2 exponent 5, so this exponent is 5. Alright, so we are done with that part. Now here we can apply the addition rule of indices, okay? So if you have a exponent m multiplying a exponent c, you're going to have a exponent m plus c. Now let's apply this concept. So we are going to have 2 exponent 5 equals 5 minus x multiplying 2 exponent minus x plus 5. All right, so this is what you have now. Okay, now we can, okay, so you're going to have 2 exponent 5 equals 5 minus x multiplying 2 exponent. Now let's rewrite our exponent, or let's reorganize our exponent. So you're going to have 5 minus x. Okay, so we have written our exponent in another form. All right, so now we have 5 minus x here, and then we have 5 minus x here. All right, now remember, our goal is to have a part, our goal is to convert a part of our question, okay, to look like the argument, or to take the form of the argument in the defining equation or the functional equation of the Lambert W function in order to do substitution. Okay, all right, now here we are going to introduce a law called the cancellation property of logs and exponentials. Okay, that is, if you have e exponent log a, this is equal to a. Okay, so if you have e exponent log 2, this will give us 2. Okay, so we can change the base of 2 to e exponent log 2. Okay, now we are doing this because in the defining equation or the functional equation of the Lambert W function, you have e. Okay, it takes e. All right, so you're going to have 2 exponent 5 equals 5 minus x. Okay, and then in place of, so you have e exponent log 2. Okay, remember there's an exponent there, so let's bring our exponent. Okay, so multiplying 5 minus x. All right, so this is what we have now. Okay, now, okay, so let's reorganize our equation. So you're going to have 2 exponent 5 equals 5 minus x, okay, multiplying e exponent. Now, so 5 exponent x comes here, okay, and then log 2 comes here. All right, so this is what we have now. Now remember, when you look at, let's visit the defining equation or the functional equation of the Lambert W function. Okay, all right, now you can see a here is the same as a here. Okay, that is the variables, okay, that are 7 as exponent, okay, is equivalent to the variable or the number here, okay, or the expression here. All right, therefore, okay, therefore we need to multiply our equation by log 2 in order to convert, okay, so that 5 minus x here is also going to have log 2. Okay, so our equation is going to be log 2 times 2 exponent 5 equals, okay, let me write it well, 2 exponent 5 equals, okay, equals log 2 multiplying 5 minus x, okay, and then you have e here, exponent 5 minus x log 2. All right, so this is what you have now. Now, 2 exponent 5 is 32, okay? So you're going to have 32. So you're going to have 32 log 2 equals Okay, here you're going to have 5 minus x multiplying log 2. Okay, then here you're going to have e exponent 5 minus x multiplying log 2. Okay, all right. All right, so now we can apply the defining equation or the functional equation of the lambda w function. Okay, so let's quote the formula again. So you have, okay, and this gives us a. All right, now before we apply this, okay, all right, let's apply straight away. So we're going to have, okay, w, okay, so let's do the substitution. So all right, so this is what we are going to have. All right, so this is what. All right, so this is what you have if you do the substitution. Okay, all right, so you're going to have, all right, so this is what we have now. Okay, all right, now let's bring this part to the left side and then move this part to the right part. Okay, so you're going to have 5 minus x, okay, multiplying log 2 equals, and then you write w multiplying 32 log 2. All right, now here we're going to divide here by log 2 and then here by log 2. So this and this cancels. So we are going to have 5 minus x equals, okay, w multiplying 32 log 2 over log 2. All right, so we want to make it the subject of the equation. Okay, so we are going to have 5 minus, okay, so here you have 32 log 2 all over log 2 equals x. Okay, all right, so this is what we have now. All right, so let's reorganize our equation. Okay, so we are going to write our equation in another form. Okay, so we are going to have x equals 5 minus w multiplying 32 log 2, okay, all over log 2. All right, so this is our final answer.